Welcome students. We are going to discuss about special class of differential equations which we'll be able to solve here. So first problem, we want to solve a differential equation dy by dx which is square root of xy where x greater than 0 and y greater than 0. So this is how the arrows, so these are your direction fields. Really. The direction fields are exactly the same as the slope field. Yeah, here you're giving an arrow to it to indicate which direction they are going in. So for example, one of the solution goes like this. So we are going to solve a special class of differential equations, which are called separable equations. So separable equations are first of all, first order differential equations, in which the expression for dy by dx can be factored as a product of function of x and y. So the idea is we have dy by dx is fx times g of y. So it's a special class of differential equation. Not every differential equation looks like this, and you can basically write it as fx times gy. So few examples are as follows. Say dy by dx equals to xy squared. So this is a separable, right? Whereas if you look at dy by dx equals to y plus e to the power x, or dy by dx equals to y by x plus 1. So these are not separable because you can't separate x and y variables. So the word separable comes from the fact, from the words to be able to separate. So not separable. This is separable. Now let's solve the following initial value problem. So this is separable, right? Because you can write it as square root of x times square root of y if x, y are both greater than, x and y are greater than 0. Then it is separable. So how do we solve it? So the way to solve this is you have dy by dx. So you separate. So first is separate x and y. X and y to different sides of equation. So we'll get what? We get dy by square root of y equals to. So first of all, you can see that clearly it is separable, right? You are able to separate it. So dy by square root of y is square root of x dx. Then second step is integrate on both sides. So if you integrate on both sides, we have integral of 1 by square root of y dy equals to integral of square root of x dx. Now integration of 1 by square root of y is 2 times square root of y equals to 2 by 3 times x to the power 3 by 2 plus a constant c. So you have found out this is not a complete solution yet. You have to solve a differential equation means to solve for y. Nevertheless, we got this now. So use the initial condition. So third, use initial condition. Namely, y of 0 is what? Y of 0, the initial condition is given to you. Y of 0 is 1. So therefore, we sub y equals to 1 and x equals to 0. So this gives us, what does it give you? It gives you 2 equals to c. or when you put it back in the equation, you get 2 times square root of y equals to 2 by 3 x to the power 3 by 2 plus 2, or you get y equals to x to the power 3 by 2 divided by 3 plus 1. And then if you square on both sides, you get y equals to x to the power 3 by 2 divided by 3 plus 1 the whole square. So this is your solution to the differential equation here. So if you look at this, y of 0 is 1, right? This is 1. And then you basically are tracing the curve along that and you get your solution. Let's look at another one. So same equation, y of 2 is 2. So here we already have the equation. We are before c, substituting the value for c, we have y square root of y is x to the power times, so what did we get? We get this equals to, so if I divide both sides by 2, I will get this by 3 plus c. So this is the equation. Now what I'll do is the following. We know when x is 2, y is 2. So put that in the equation. So we get, therefore we get square root of 2 equals to 2 to the power 3 by 2 divided by 3 plus c. So therefore we get c equals to root 2 minus 2 root 2 by 3, which is same as root 2, but this is same as 3 root 3 minus 2 root 3, so it's going to be root 2 by 3. So that is what your value of c is, and hence your solution becomes square root of y equals to x to the power 3 by 2 by 3 plus root 2 by 3, or y equals to x to the power 3 by 2 by 3 plus root 2 by 3 the whole square. So you see, it will correspond to the solution. This is point. So x, when y of 2 is what? Y of 2. So y of 2 is 2, right? So this is a corresponding solution. Now let's look at another example. Find the general solution for dy by dx equals to 2 square root of y minus 1. So again, what we do is, this is a separable equation. So separate, we get dy by square root of y minus 1 equals to 2x dx. Then we integrate to integrate. When we integrate, we get integral of dy over square root of y minus 1 equals to integral of 2x dx, which gives me y 2 times square root of y minus 1 equals to x squared plus a constant c, which can be written as y minus 1 square root equals to x squared by 2 plus c by d. So let me call this constant c bar by 2, which is going to be d or c, where c bar by 2 equals to c. Yeah, the idea is to write it as a nice, so as a simplest as possible. So we have y minus 1 squaring on both sides, we get x squared by 2 plus c the whole square, and then if you bring this 1 on the other side, it becomes y equals to this. So general solution. So this is a general solution. Now we don't put any values. We only do step 3 when we have initial condition. So here we went for step 3 when we had the initial condition. Since we have no initial condition here, this is a general solution. Yeah. So you can see that some of the solutions will look like this. Yeah. Say one solution is like that. Another solution is like that. Yeah, and if you see that that is roughly like x to the power, this is like a parabola really, right? But it has x to the power 4 in it. So it's like a contract, like a parabola, which is slightly compressed, all right? So you know the x to the 4 graph looks like that, right? So these are the solutions, and each solution depend on what initial condition is. So suppose if your y of 0 was 2, then you would have chosen y of 0 is 2. So somewhere here, you would have chosen this as a solution. So this solution corresponds to y of 0 equals to 2. Okay. Now let's look at the following. Again, we have dy by dx as y. So in this case, what we're going to do is first, again, we'll separate it out. So separate. So we have dy. So we have 1 by 1 plus y square divided by y dy equals to cos x dx. Now integrate. Step 2, integrate. We have 1 by y plus y dy equals to integration of cos x dx. This gives me ln of absolute value of y plus y squared by 2 equals to sine x. And I can write plus c at any side, doesn't matter which side you write. Now this function, so generally we solve for y. So this is implicitly defined. This is an implicit function. Yeah, this is not an explicit function. So sometimes we cannot, so sometimes we may not be able to write y equals to f of x. Yeah, so that's fine. This is an implicit defined equation. Yeah. If, for example, here the solution corresponds to, in this case, just tracing one of the paths and then tracing another one for the same value of y, see that this is one of the solution. Yeah. So it cannot be written as a function y as a function of x. So sometimes this is not possible to do. Now let's look at the following problem. Find the equation of the curve that passes through 1, 1 and whose slope at xy is y squared by x cubed. So slope means what? We have, this means that the derivative is the slope, right? So derivative is, slope is y squared by x cubed. And what else is given? We are given that y of 1, when x is 1, y is 1. So y of 1 is 1. So now your equation has translated to the following initial value problem. Can we solve this? Yes. Why? Because this is separable. So this is separable. So this is separable. So therefore, step one, what we'll do is separate out. Yeah. So separate. So when we separate, we get dy by y squared equals to dx by x cubed. Step 2, integrate. So when we integrate, we get integration of dy by y square equals to integration of dx by x cubed. This will give me, what is integration of this? Is minus 1 by y equals to minus 1 by 2x square plus c. Now we can use the initial condition. So for that, we'll find c. So to find c, we have minus 1 by y So first of all, I can get rid of the minus sign. So I get minus 1 by y. So I can write this as r. Let me write this c bar, or I get multiplying by minus sign, I get 1 by y equals to 1 by 2x squared plus c. Yeah. So when x is 1, y is 1. So this implies 1 by 1 equals to 1 by 2 plus c. So which implies c must be 1 over 2. So therefore, what do we get? Therefore, 1 by y equals to 1 by 2x squared plus 1 by 2, or this is same as 1 by x squared divided by 2x squared, which gives me y equals to 2x squared divided by 1 by x squared. So 1, 1, if you look at this solution, this is one of the solutions. So y of 1 equals to 1. So y of 1 is here somewhere. Y of 1 is equal to 1. So we have to trace this guy. So y 1, 1 lies on this curve. So this is a solution. Yeah. Note that there are other solutions as well. They depend on the initial condition. Okay. Now let's look at few applications of separable differential equation. So applications. So for example, find the orthogonal trajectories of the family of curves x squared minus y squared equals to k. So first of all, what is an orthogonal trajectory? So if you're given a family of curves, then an orthogonal trajectory of this family of curve is a curve that intersects each member of the curves at right angle. So let's see, for example, so these are orthogonal families of curve. Sorry, these are what? These are families of curve. And now look at this guy here. So these are families of curve. And what is an orthogonal trajectory? Orthogonal trajectory is something which intersects these curves at what angle? At 90 degree. So if you look at tangent here, it is 90 degree. If you look at tangent here, it's 90 degree. Tangent here, it's going to be 90 degrees. So this is the idea behind the orthogonal trajectory. So again, what is the orthogonal trajectory of a given family of curve? It's a curve, a single curve that intersects each member. So it's intersecting each member of the curve at 90 degrees. So how do we solve this? So we have x squared minus y squared equals to k, and we want to basically find out what is that term. So 1. So first of all, find a differential equation, a single differential equation that is satisfied by all the members of x square minus y square equals to k. And how do we get that? Differentiate. With respect to x, we'll get 2x minus 2y times dy by dx equals to 0. This gives dy by dx equals to x over y. Now note that orthogonal family means orthogonal means the product of slopes. But lines do not have, but curves, what do you mean by two curves are orthogonal? What do you mean by slope of an slope of a curve? Slope of the curve is basically the slope of the tangent line to the curve. So slope of the curves must be -1. So therefore we get what? We get orthogonal for orthogonal trajectory to trajectory, we have dy by dx equals to what? It should multiply to give you -1. So it will be minus y over x. It's a negative reciprocal. So now we have this. Third, solve this dE. Solve the differential equation. So we have what? We have y, we have dy, so it's separable, so we can solve it, over minus y equals to dx over x. So we get from here, so dy over minus y equals to dx over x. So we get ln of absolute value of y with a minus sign equals to ln of absolute value of x plus a constant c. So this would imply, bring it on one side. So we have, let's bring this on this side and c on the other side. So we have ln of x minus ln of y equals to some constant, another constant. So let's call the c bar. So minus c bar, which is same as c. Or we get ln of x over y, sorry, x over y equals to, so we get ln, when you bring it on the other side, it becomes plus. So we get ln of x times ln of y, sorry, ln of x plus ln of y is ln of xy, that is c. Or we get xy equals to e to the power c. Or we get xy equals to plus or minus e to the power c. Let's choose to call it another constant, say d. So xy equals to d, and that will be the so y equals to d over x, or xy equals to d, gives me the orthogonal family. Okay. So since we want to find out what is the amount of salt, so in the tank at time t, so let y of t be amount of salt in the tank at time t. Yeah, and this amount is measured in what? In kilograms. Measured in kilos. So measured in kilograms. So now what is the rate of change of salt? So dy by dt is the rate of change of salt, or rate of change of amount of salt. So this is going to be rate of addition of salt minus rate of removal. And also on top of that, so let's look at this. So what do we get? What is the rate of addition? So how much salt is entering the system? So first of all, we have zero 0.5 kilogram of salt per liter is entering. So this is going to be 0.05 kilogram per liter. And how many liters are coming in? We have 5 liter per minute. So 5 liter per minute. Then there is another source, brine containing 0.04 kilogram of salt per liter of water enters the tank at the rate of 10 liter per minute. So we have 0.04 kilogram per liter. And how many of these liters are coming? 10 of these liters are coming per minute. If we cancel these liters, so if you do the dimension analysis, you will see that it is indeed kilogram per minute, which matches exactly with the dy by dt. So we get this is going to be 0.05 times 5, so 0.25 kilogram per minute plus 0.40 kilogram per minute, which is going to be 0.65 kilogram per minute. This is the rate of addition of salt. Now, what is the rate of removal? So the tank, note that, has a volume always of how much? The volume of the tank is 100 liters, no matter what, right? If the 15 liters are coming in, 5 liter plus 10 liter, how much liter is going out? This is drained, and 15 liters of that is drained out. So now the question is, how much salt is going out of system at any point? So of course the salt is not going on its own, it's mixed in the water. So we need to see what is the concentration of salt in the water. So concentration at time t, why? Because we are saying how the 15 liter of this mixed water is going out. Then what is the salt in this 15 liter? So first we need to know how much salt is in 1 liter. So concentration at time t is y of t divided by 1000. So whatever the amount of salt is, it is distributed in 1000 liters of water. So therefore, rate of removal is y of t divided by 100 kilogram per liter, and out of that, how many liters are leaving? 15 liters. So 15 liter per minute, and that can be written as, if you do the cancellation, it will be 3 by 200 kilogram per minute. So therefore we get dy by dt equals to rate in minus rate out, which is going to be 0.65 minus 3 by, multiplied by y, right? Because y is also there. Y2. Yeah, you should check out the units. So unit should work out, which is going to be so if you multiply this, is going to be 130 minus 3y divided by 200. So this is your differential equation. Now let's see, is there anything else given to us? If you notice, we are given that the tank contains, at the start of it, tank contains pure water. So 100 liter of pure water, that means the amount of salt at time t equals to 0 is 0 because the water is pure. So we need to solve this equation. So solve about. So we have converted this mathematical problem, we have modeled this problem into a differential equation now. So once that is done, then the problem becomes absolutely of differential equation. So again, first separate. When we separate, we write dy over 130 minus 3y equals to dt over 200, which implies step 2, integrate. So if we integrate, we get integral of dy over 130 minus 3y equals to dt over 200 integral of that. So this gives us, when we integrate, we get 1 by, so ln of absolute value of 130 minus 3y divided by minus 3 equals to 1 by 200 t plus c. So we got this. Now we can solve for c. Third, solve for c. So how do we solve for c? We take y of 0 is 0. So when you put y of 0, you get what? You get minus 1 by 3 ln of 130 equals to c. So therefore the equation becomes, we get ln of 130 minus 3y divided by minus 3 equals to t upon 200 plus, minus ln of 130 divided by 3. Now bring those things together and combine. So we get, you can multiply throughout by 3. So you get, and then bring this on the other side. So we get ln of 130 minus 3y equals to minus 3t by 200 plus ln of 130. Yeah. So this is going to be, now I can change this into ln in the following way. I get 130, or raised to power e on both sides, either way. I get absolute value, raising it to power. I can write this as e to the power ln of minus, I can write this as e to the power minus 3 by 200 ln of this, right? Because ln and e will cancel. The idea is to combine these two together. Which way you combine, it's up to you. So I'm going to combine it using like that. And this becomes 130 e to the power minus 3t by 200 equals to absolute value of 130 minus 3y. So I can get rid of ln from both sides. So first I should write maybe one more step, ln of this equals to ln of this. So ln is a 1 function, so I get 130 minus 3y equals to 130 e to the power by 200. So this will give me y equals to 130 minus 3y equals to 130 e to the power 3 by 200. So now why is that? Because this side is always positive. Why? Because this side is positive. So we get, therefore we get y equals to, let's bring this on the other side. So 130 minus 130 e to the power minus 3 by t 200 divided by 3. So this is the solution. All right. You could have basically, so again, I mean, we could have done this. We could have not gone through all this, simplified, and then tried to do this. So this is your solution. Now question, so A, this was A, part A. So this is the amount of salt at time t. So B, what happens after 30 minutes? So after 60 minutes, right? Because that's what the part 2 is, after 1 hour. So after 1 hour, since everything is measured in minutes, so we have t equals to 60 and we have y of t equals to 130 by 3 e to the power 1 minus e to the power 3 times, so minus 180 divided by 200. And if we use a calculator, you'll see that this is roughly 25.7 kilograms. Now question C, which is not mentioned there, what happens as t goes to infinity? As t goes to infinity, y of t goes to what? So y of t will go, this will become, this part will become 0, right? So we get y of t goes to infinity, y of t goes to 130 by 3, which is roughly 43 and 1/3 kilograms.